Good morning, students. Myself, Dr. J.P. Sridhar, Associate Professor, Department of Electrical Engineering. Today, I am going to discuss an AC circuit contains pure resistance. Okay, one of the important topic in single-phase AC circuits. So, in this topic, we can discuss what is the effect of current, voltage, and power when an AC circuit contains pure inductance value. Okay, let us consider the circuit. It goes like this. Let the circuit. Okay, so whenever the AC contains a pure resistance, there is no other elements present in the circuit, we will have only resistance. Across this we are connecting an AC supply. Its instantaneous value is given by V is equal to Vm sin omega t. So this is the circuit. So we know that here there is only one component, that is resistor, and we can see the effect of the current, voltage and power in the AC circuit which contains a pure resistance value. Now according to Ohm's law, we know that I is given by V by R. Now what is V? V is equal to Vm sin omega t is the instantaneous value of the voltage. Similarly, what is the current value of instantaneous? It is nothing but I is equal to Im sin omega t. This is the instantaneous value of the current in AC circuit. Now, I will substitute the value of V in this Ohm's law. I can rewrite the equation. So, I is equal to, whereas V can be replaced by Vm sin omega t divided by R. Okay, this is the equation. Now I can rewrite this equation. I is equal to Vm by R into sin omega t. Okay, so now compare this equation 3 with equation 2, we can come to know what is the value of Im. So from we compare equation 2 and 3, so what is Im? So Im is equal to Vm by R. Im is equal to Vm by R, and you can compare the phase angle here, omega t of current, and you can see the voltage phase, both will have omega t. So automatically the phase is pi is equal to 0. It means that in case of single phase AC circuit, the voltage and current will start from same phase. Okay, if it will not start from same phase, the voltage has to be either leading or lagging. We have to represent it by a phase difference. Either it may be a phase difference, may be either positive value or negative value. Now we can see the equation now here. So the Im is equal to Vm by R, as pi is equal to 0. It is nothing but voltage and current are in same phase. Okay, so therefore in case of an AC circuit contains pure resistance, the voltage and current are in the same phase, same phase. So hence we have to draw the phasor diagram for the purely resistive circuit. Okay, I will take the voltage as the reference vector and current, we know this is in same line with voltage V because cos pi is equal to 0. So we can draw the voltage waveform of current and voltage in case of an AC circuit. If you take, okay, it's an voltage waveform. It is given by V is equal to Vm sin omega t. P is equal to Vm sin omega t, and current also be started from the same point. Okay, so this is the current waveform. It is given by I is equal to Im sin omega t. As you observe here, both the waveform, that is voltage and current vectors, are starting from the same point and terminate at the same point in the given cycle. So their phase difference is 0. Hence cos pi is equal to 0 in case of resistive circuit. Okay. Now this is the voltage and current waveform. Now we have to one more parameter, that is called power. Then what is the effect of power when AC circuit contains a pure resistance? Now we can see that what is the effect of power. Now what is the power equation? We know the instantaneous power equation is given by P is equal to V into I. So what is the equation for V and I? We know already. So P is equal to V is nothing but Vm sin omega t. And what about Im? Ia is equal to Im sin omega t in case of pure resistive circuit. Now I will simplify this. P is equal to Vm into Im into sin square omega t. Sin omega t into sin omega t can be written as sin square omega t. We know that a trigonometric function sin square theta can be written as trigonometric functions sin square theta can be written as 1 minus cos 2 theta. 1 minus cos 2 theta. Here what is theta? Theta is omega t. Now apply this trigonometric function in the power equation. Then I can rewrite the above equation like this. P is equal to Vm Im into sin square theta can be written as 1 minus cos 2 theta. So 1 minus cos 2 theta is nothing but omega t cos 2 omega t. I will simplify this expression now. So I will continue. P is equal to Vm. So you can write 2 sin square 1 minus cos 2 theta by 2. Therefore Pm is equal to Vm Im by 2 into 1 minus cos square 2 omega t. Now I will multiply this equation. So P is equal to Vm into Im by 2 minus Vm into Im by 2 into cos 2 omega t. Cos 2 omega t. Okay. So now what is P now? So P is equal to, I will rewrite once again, Vm Im by 2 minus Vm into Im by 2 cos 2 omega t. Okay, you can observe the second part of the power equation. So this is a fluctuating component. Okay, here the frequency is, the fundamental frequency is 2 times the normal frequency. So therefore its value over one complete cycle is 0. Its value over one complete cycle is 0. Therefore this term will be 0. Then what is the remaining term? Remaining term will be P is equal to Vm Im by 2. So I can simplify this power equation as Vm by root 2 into Im by root 2. So therefore what is Vm by root 2? Vm by root 2 is V, that is RMS value. Then Im by root 2 is I. This is the expression for power. Okay, P is equal to V into I watts. Unit is watts in case of an AC circuit contains pure resistance. So suppose it can also be written as what is V, as per Ohm's law, I into R. So we can also write P is equal to I square R watts. I square R watts. Now we have to draw the phasor diagram of an AC circuit. I will write it here. We'll have the current vector. Okay. We'll have the voltage vector. Then the phase difference is same. Okay. So okay. Next, what is the power equation? Power equation you can observe P is equal to V into I. So only the first component is present in the equation. Okay, the second part is 0. Okay, so therefore we can write the power equation as, in the negative half cycle, that value will be shifted. Okay, and we can get the power expression as, okay, like this. The equation for Fm for power, and we'll have the equation for voltage, expression for current, this is time, this is the average power, this will be the average power. Okay, so this is the expression for P and voltage, current and power waveforms in case of AC circuit contains pure resistance. So with this I will conclude.